All right, page 512 in your textbooks, you had numbers 22 through 33 for homework, practicing with reducing radicals, making the radicand simpler. The idea being we are factoring the radicand so that one of the factors is a rational factor. All right, let's quickly review for square roots. What are those rational factors we're shooting for? Those factors we're hoping to see in our numbers. Yeah, the square root of 4 we could take evenly, right?
9.
We could take the square root of 9 evenly.
16.
The square root of 16 we could take evenly.
36.
The square root of 26.
36.
36 we could. We skipped one. Square root of 25.
81.
Square root of 81. Square root of 49.
64.
Square root of 64. There's a lot of different ones. Here's the key ones that I want you to note. The square root of 4. Square root of 9. Now here's the deal. If there's not a 4, there won't be a 16. Because to have a 16, there has to also be a 4, because 4 is in 16. If you don't have a 9 or a 4, you won't have a 36. You could have a 25. 49 is a weird one. You won't see it very often, but then the square root of 100. These are the big 4. Now, how do I know there's a 100 inside my number, Hayden? If it ends in 00. Now, granted, that also means a 25 works, but why would I factor with a 25 when I could factor with 100? There are some endings, though, for 25 as well. I know we're going to have a 25 if it ends in, Danielle?
25. 35.
Or?
00.
Well, yeah, but there's a couple other endings. Think quarters.
75.
75, or?
50.
I was asking Danielle. So 25, 50, 75. Again, technically, yes, 00, but I could get 100 for that. Now, for 9, we go back to our divisibility rules from earlier in the year. Here, remember, it's if the sum of the digits is divisible by 9. Okay, so you know there will be a 9 in there if you could add up the digits, and it adds up to a 9 and 18, 27. That'd be a really big number. And then finally, for the 4, remember, our divisibility rule is if the last 2 digits are divisible by 4. Now, if you don't have any of these, try the 49. The 49 is your nothing else is working, let's try that. The other option would be for really big numbers. Remember, we said you could try cutting the number in half and seeing if you come up with a square or something. Well, let's take a look at the homework here. And on number 22, they already factored it for you. They already factored the 5 and 36. Which of those two numbers am I going to take the root of, Aubrey? The 36 to get. But I can't take the square root of 5, so I just leave the square root of 5. And we should have had 6 times the square root of 5 for number 22. Number 23, we had the square root of 25. Why? Well, 25 is already a square. So we just take the square root of 25, Lexi. 5. But I can't really do anything about the y, so I just leave
the root of y.
The square root of y. And we get 5 times the square root of y. How many have these first 2 correct? I thought those were pretty straightforward. The next one you actually had to figure out on your own. And Glenn, how do we factor up the 27? I'm sorry? Yeah, but how do we factor it? Like, what factors do we write? 5 goes into 27?
I know, 9 and 3.
9 times 3. We specifically want either a square root of 4, that doesn't go in 27, square root of 9, square root of 25, that doesn't go in. Obviously, square root of 100 doesn't go, so we're going to go with the square root of 9 and 3. We're going to take the square root of the to get, and we're going to leave the square root of 3. How many have this answer for number 24? Number 25, we have the square root of 28. Evie, how are we going to factor this?
4 and 7.
4 and 7. And we're going to take the square root of the
4
to get,
2.
and we leave the
Square root of 7.
and there's our answer, 2 times the square root of 7. Number 26, how did you factor it, Hayden?
9 and 11.
9 and 11, and your answer was
3 times the square root of 11.
3 times the square root of 11. Excellent. For number 27, how should we factor that, Aubrey? 6 times 100, where we take the square root of the to get, so our answer is 10 times the square root of 6. Excellent. Number 28, we have the square root of 6b squared. Is there a way to factor a 6, Danielle, so that one of these is a factor? No. I can't do anything with the 6. But remember we said, class, to take the root of a power, divide the exponent by the index. And I can evenly divide this exponent by the understood 2 index. So while I can't take the square root of 6, I can take the square root of b squared.
B.
Right, b to the first, or just b. And so b times the square root of 6 is our answer. How many figured that out on number 28? I think we had one problem like that in our last lesson. Questions on that? Looking at number 29. It's not one of these. There's another one that should be pretty obvious here, Lexi. How should we factor the 360?
Oh, I accidentally did this one wrong.
Okay, so how should we have done it?
49? Or no, the 25.
It's kind of right there screaming at you. Look at the number, 360.
Oh, that's 4. The 4.
4 would work, it's true. Even 9 would work. It's not one of the big 4. It's another one, but it's kind of right there.
36.
36 times.
Oh, times 10.
10, there we go. So sometimes it kind of screams at you. And so we would take the square root of the 36 to get
6.
Times the...
The square root of 10.
There we go, times the square root of 10. Now that's not the only way to do it, obviously. There's other ways you could have approached this one. Let's suppose, Lexi, you mentioned a 4. You could factor this into 4 times 90. Where, Glenn, if we did this, we would take the square root of 4 to get 2 times the square root of 90. But can I stop there, class? You don't stop reducing, just like we don't stop reducing a fraction until we're done, we wouldn't stop reducing the 90 until we're done. I could still factor the 90, Evie, into...
Times 3.
I'm sorry?
30 times 3.
Well, 30 and 3, but can you take this?
9 times 10.
Yeah, you can't take the square root of either of those, but 9 times 10 you could. You could take the square root of the 9 to get
3.
Times the 2.
6.
And notice there's the same 6 times the square root of 10. Another option would have been to factor this initially into 9 times 40. If we did that, Hayden, we take the square root of the 9 times the square root of 40, but we can't stop there, Aubrey. 4 times 10, where we're going to take the square root of the 4 to get, and notice we still get 6 times the square root of 10. The quickest way would be this way, but the other ways work. How many got to 6 times the square root of 10 regardless of the way you approached it? Good. Did any of you get to one of these other answers and stopped just too soon? Like you did it okay, you just didn't finish 2 square root of 90 or 3 times the square root of 40? Questions at all on the square root of 360? All right, let's take a look at the next one, the square root of 325. How did you factor the 325? Danielle?
I did the 25 and 13.
Good. It's the only way to do it. It feels like there should be a quicker way, but you got the ending in 25. You get what you know is there, right? 25 times 13. And so our answer ends up being?
5 times the square root of 13.
5 times the square root of 13. Great job. Number 31 is already factored. Square root of 16, square root of 49, but we can take the square root of 16, Lexi.
4.
And the square root of 29.
7.
So our answer is rational.
2 to the square. 2 times the square root of 7.
Ooh, okay. You overthought. So you said the square root of 16 is? 4. And the square root of 49 is? 7. Notice there's nothing left to need to take the square root of. So the square root symbol's gone. We've done what it said to do. We just got to figure out our answer. 28. And we're done. That's all. So that one actually worked out rationally. Number 32, Glenn, they've written it with exponents. 3 to the 4th and 11 squared, but the square root of 3 to the 4th. I'm not looking for the final answer. What's the square root of 3 to the 4th? Remember to take the root of a power, divide the exponent by the index, right? Now 3 to the 4th is 81, Glenn, that's true. But I don't even need to do that. I just need to divide the exponent by the index to get 3 squared. Now, if you change this to an 81, the square root would be 9, which is 3 squared, right? So it's not wrong necessarily. The square root of 11 squared, 11. Again, if you wrote it as a 121, the square root of 121 is 11. This is 9, and so our final answer is 99. And notice we were able to take the roots completely here. Looking at the next one, number 33, Evie. When we divide exponents by index, it works out evenly for us. We end up with?
M squared and cubed.
M squared and cubed, because 3 goes into 6 twice, 3 goes into 9 3 times. We're good to go. Anyone 12 for 12? You got every one of them right. Wow. Anyone just missed one or two of them? Just missed one or two. Got most of them, just a couple little things. Okay, any questions on the one or two that we missed? Any questions? All right. Let's go ahead and take a look at, we saw a couple problems here with letters. For instance, the one Evie just worked a moment ago had letters in it, and the letters worked out evenly. But letters don't always work out evenly. Off to the side of the book, or maybe flip back a page. I think if you flip back a page, maybe there's a little, maybe a couple pages. Flip back a couple pages there to page 509. Page 509. And there's a little bit of space kind of there in the margin that you can write. I want you to write this problem down. The cube root of 54x to the fifth. The cube root of 54x to the fifth. Now, first thing we notice is we got a cube root. All day yesterday, everything we did was with square roots. These numbers are great for square roots, but they're horrible for cube roots. What are some of the numbers we could take cube roots of?
8.
Okay, you could take the cube root of 8.
64. 27.
You could take the cube root of 64.
27.
You could take the cube root of 27.
125.
125. Okay, these are really the only numbers I like to try to use. I will say the 64 is a little more awkward to use in some cases, and 8 will work. But 8 and 64, you would only use these guys if you have an even number. Right? If it's an odd number, 8 and 64 aren't going to work. If it's a 125, the number has to end in 5. Now, that doesn't mean the 125 is definitely going to work, but if it doesn't end in 5, you can't use 125. 27 is kind of what I use for other odd numbers. Okay? Now, not all odd numbers will work with the 27. They might work with the 120. But these are kind of basic guidelines. They're not hard and fast rules, but these are the cubes I'm looking for. But here, that even breaks down a little bit, right? I mean, it's kind of an awkward construct here. 54. Yeah, although it's not an odd number, 27 works, right? So again, cube roots are a little bit harder to use, but you don't have very many of them to use is the upside. 27 times 2. And notice for the number, we're still just factoring it like we've done before. And for now, I'm going to leave the x to the fifth. We'll take the cube root of the 27 class. 3. And we'll leave the cube root of the 2. No problem so far, right? But then we come to the letter. Can I take the cube root of x to the fifth? 3 doesn't go into 5 perfectly, does it? But it does go in. And we know that to take the root of a power class, exponent by the index. Now let's suppose I were dividing something like a 3 into, say, a 375. Well, I would divide it and say, how many times, this is what division is asking the question, how many times does this go into that? How many times does 3 go into 3?
Once.
How many times does 3 go into 7?
Twice.
Twice, but there's 1 left over, isn't there? Now that kind of carries over. 3 goes into 15. 5 times. How many times does this go into that? But what if it were only a smaller number, like 3 into 7? Well, 3 goes into 7 twice with 1 left over. We'd call that a remainder, wouldn't we? We're going to use this remainder idea here. 3 goes into 5 how many times? Once. So when I divide 5 by 3, I get 1 evenly. But there's a remainder of 2. And the remainder remains in the house, in the radicand. So I'm going to remain with that. Make sure you've got this example copied into your notes there on page, whatever it was. 509. Page 509. Make sure you have that example copied there onto page 509. How many times does this go into that? The number you're still doing the old way. But when it comes to the letters, when it comes to the exponents, if it doesn't divide evenly, get what you can, leave what you can't. 3 goes into 5 once, great. There's 2 leftovers. Leave them in the house. Write this down if you would. The square root of 32 mn squared p to the 6th. The square root of 32 mn squared p to the 6th. With the 32. Now again, these aren't all of them, but one of these will work. There's actually another one we could use that's not on the list. How might I factor up a 32?
16 and 2.
You could factor it into a 16 and 2. You could also go 4 and 8, right? 16 is better if you happen to see it. If you don't see it, go with 4 and 8. It's not going to be a problem. By the way, if you did go with 4 and 8, Do you see the 8 could factor again? 4 and 2. So you can take the square root of the 4 to get, and the square root of this 4 to get, and you end up with 4. Same as if you split the 16 in 2, right? There's the 16, there's the 2. So we'll take the square root of the 16 class, 4, or the square roots of a couple of 4s to get 4, and we're going to leave the 2. When you come to the letters, you're asking yourself, as I write in the understood 1 and the understood 2 strategy tip, you don't have to, but I recommend it. The question is, how many times does this go into that? How many times does 2 go into 1, class? None. So do any m's come out? No, it can't. So I'm going to have to leave the m in here because it didn't do anything. Make sense? It doesn't cease to exist just because 2 doesn't go into 1. It just, nothing comes out. How many times does 2 go into 2? Once. With how many left over? None. There are no leftovers. It's like when the family eats all the food. Okay, no leftovers. How many times 2 go into 6? 3 times. How many left over? None. No leftovers. That's okay. If there were, you'd leave them. If there aren't, you don't. Yes?
After we're done with the whole thing, do we have to leave the 1?
No, good question. If you like, take the 1s off, no problem. And there's our answer. Questions on that? One more example to write in your books. Write this down. The cube root of 5, a to the 7th, b squared, c to the 12th. The cube root of 5, a to the 7th, b squared, c to the 12th. These are my numbers I'm shooting for. Are any of these in a 5? No. So can I do anything with the 5? Then just leave the cube root of 5. You can't do anything with it anyway. Easy enough? Now then, we saw that in the homework, right? I think it was a square root of 6. We couldn't do anything with it. Cube root of 5, same way. When we come to the letters, and with the letters, class, we know we divide the exponent by the index. So the question for division is, how many times does this go into that? In this case, how many times does 3 go into 7? Answer? Twice. So write 2 down outside. How many left over? 1. Write it down inside. 3 goes into 7 twice, and there's a single leftover. So leave the leftover in the house. The next question, class, is how many times does 3 go into 2? Answer?
0.
None. If you wanted to, you could say b to the 0. I don't want to, I'm lazy. But you could, right? Anything to the 0 power is 1, which means it doesn't affect anything anyway. But 3 goes into 2 no time, so nothing comes out. So what do I do with the 2 b's?
Put it inside the thing.
Leave it where it is. Then I ask myself, how many times does 3 go into 12? 4 times. How many left over? None. No leftovers. That's fine. Starting to catch on to how to work with the letters. Questions on that? Flip back to page 500, or flip over now to page 511. And let's do a couple of these together here. Number 37. Number 37, they start us off with the square root of a 3 to the 4th times 5. Well, I can take the square root of 3 to the 4th because 2 can go into 4 how many times, class? 2. So I get a 3 squared. How many left over? None. How many times does 2 go into 1? None. So what do I do with the 5 to the 1st? Just leave it. And then what's my final answer when I simplify? Times the 9 times the square root of 5. See how we can even technically do it with numbers with exponents, just normally letters are the things with the exponents. So how about on the next one, we've got a cube root of a squared b to the 6th. Glenn, we're going to ask ourselves, how many times does? Answer? None. So what do I do? Just leave the a squared in the cube root, in the radicand. Then I ask myself, answer? 2 times. With how many left over? None. So I write the b squared outside, don't leave anything inside. Feel like we're catching on? Let's take a look at the last one here. We've got the square root of n to the 7th. What question do I need to ask myself here? Danielle?
How many times the cube goes into 7? No, the square.
So what's the index?
Square?
So what number is that?
2.
A 2, right. So we're going to write the little understood 2. It just helps to see the 2, I think. And so we ask ourselves, you said, how many times?
Does 2 go into 7?
Answer?
3
with,
1 left over.
so how do I write that?
You're gonna put n to the third cubed on the outside, and then on the inside you're just gonna put n to the first.
Good, or just
leave
n. Could you write the 2 and the 1 here? Sure, do we need to? No, so we just leave it like that. Questions on this? Let's take a look at number 41. No letters, just number, but it's a big number. Square root of 162. What's the strategy for a great big number?
You could use the
So like I said yesterday, if it's a big number in the radicand, instead of trying to see, does 4 go in? Does 9 go in? By the way, does 9 go in?
Yes.
1 plus 6 plus 2 is 9. 9 would work, but that could take us a while when the number's really big. So I said, if it's a big number, try cutting it in half. If that doesn't work, try cutting it in thirds. In other words, factor it into 2 times something and see if what you get works.
81.
Does that work?
Yes.
Yeah. And that ends up giving us what for our answer here? Hayden?
9 squared times, or 9 squared times 9 squared.
Hayden.
I'm so confused.
We have factored the 162 into 81 times 2. The reason we factored it is so we could take the square root of one of those two numbers.
81.
Yep, so we take the square root and what do we get?
9.
9. And then
Times the square root of 2.
times the square root of 2. There we go. Not 9 squared, just 9 times the square root of 2 is our answer. Now, again, would it work if you said, all right, 9 goes in, let's see, 9 goes into 16 class, once with 7 left over it, and 9 goes into 72. Okay, so apparently 9 times 18 is how we factor. I mean, we didn't memorize that higher in our times tables, but 9 times 18 is 162. We take the square root of the 9 class, 3 times the square root of 18, but I can factor this again. 18 factors into class?
6 and 2.
Oh, that doesn't help.
9 and 2.
9 times 2. And I can take the square root of the 9 class, 3. Now, I already had a 3 out here. I now have another 3, so that's 9 times the square root of 2. Same answer, right? But it's quicker if they have a big number, try cutting it in half. If that doesn't work, try cutting it in thirds. For instance, if I had a number like, oh goodness, 675. Oh my. Now it would work to start with a 25, but it might be faster since it's so big if I said, well, let's try cutting it in half. Wait, can you cut this in half? That's, no. Could I try cutting it in thirds then? Because it's not an even number. Okay, could I try cutting it in thirds? 3 times something.
5.
3 goes into 6.
2.
3 goes into 7.
2.
3 goes into 15. Oh, wait a second. We can take the square root of this. It's 15 times the square root of 3. Again, big numbers, that's my recommended strategy. Because otherwise, I mean, we could do, if you noticed immediately, hey, it ends in 75, 25's in there. We could factor into 25 times, how much times 25 go into 67? Twice. That's 17 left. How many times does 25 go into 175? $1.75, how many quarters?
7.
7. So we could factor in 25 times 27. I don't want to, but I could. That would give me 5 squared root of 27, and then I could factor the 27 class. 9 times 3, where I pull out a 3, and there's the same answer. But again, it's just quicker. Try cutting it in half, or try cutting it in thirds. See if maybe the number you get isn't one of your bigger squares that we've seen. Let's drop down now to number 43. We have the square root of 2n cubed. Lexi, what do we do here?
You do the n, the 30, divide the 2 by the 3, and how many times is 2 going to 3?
Okay, so you've already given up on the number, right? Because you can't do anything with a 2, right? So you're going straight to the index. You're saying how many times 2 go into 3?
1.
Okay, so
N times the square root of 2.
good. Leave the 2, you can't do nothing with it. 2 goes into 3 once with 1 left over, and we get n times the square root of 2n. Questions on number 43? Number 45, we have the square root of 5x to the 5th. And Aubrey, walk us through. What do we need to do here? I'm sorry?
Leave the square root of 5.
Yeah, leave the square root of 5. Can't do nothing with that.
And 2 goes into 5 2 times.
So we write an x squared out here.
Then 1 left over.
And there we go. How many had that for number 45? Feel like you're getting the hang of this? Right. Number 47. We have the square root of x squared y to the 7th. What do we need to do here, Evie?
Let's see how many times the index goes into that next one.
Good.
It goes in once for x. And then goes into y 3 times.
Good.
And then you're left with 1.
So we're left in our square root with a single y remaining. There we go. We don't necessarily, of course, have to write the ones, but it's not wrong to have it either. It wouldn't be wrong to have the index of 2, though again, don't have to write that there. How many think of the same thing Evie was thinking there? Any questions on this? Feel like we're getting the hang of it? All right, you do 40 through 48 the even. Do 40 to 48 the even now. In numbers you factor, letters you divide exponents by index. Just a little longer to be finishing up these 5 problems, and then we'll take a look at them. Just take your time, put your pencils down. Even if you're not finished, I guess if you're watching on YouTube, you can pause it and finish on your own. We come to the 98, and I'm like, does 4 go in? 9 go in? I already know these two don't work. If 4 doesn't work, you know 16 doesn't work. If 9 doesn't work, you know 36 doesn't work. So those are knocked out. This is one of those examples where it's just kind of a weird one, isn't it? What's the number I said if it's just kind of weird, Glenn? 49, and it does work. Or you think of this as a big number, try cutting it in half. And if you try that approach, you also come to that 49. So we end up getting what for our answer? 7 times the square root of 2. How many figured that one out? 7 times the square root of 2. Questions on that? We got to 252, and my first thought is, hey, this is a big number. Let me try cutting it in half. But if you divide by 2, did anyone do that? What do you get?
I got 126.
Yeah, 126. Can I take the square root of that, class?
No.
Okay, maybe I can try cutting it in thirds then. Okay, let's try dividing it by 3. Anyone try that? Divided by 3, you end up with an 84. That doesn't help either, does it? All right, so, all right, forget that method. Which of these numbers has got to work? The 9. You add up those digits, 2, 5, 2 adds up to 9. I'm just going to go that method. I tried a shortcut, and my shortcuts weren't working for me. But I can divide it by 9, or factor it with a 9. 9 times 18? No. How many times does 9 go into 25?
2.
2 times. So I know it starts with a 2. How many left over?
8. No.
7.
7.
How many times does 9 go into 72? 8. All right, so 9 times 28. How many factored 9 and 28? Okay, there's another way you could have approached it. We take the square root of the 9, if we've done it this way, class. 3 times the square root of 28, but I'm not going to leave 3 times the square root of 28. Why not, Lexi?
Because 28 can be divided, or
Factored.
To 14?
Well, 14 and 2, but 14 and 2, neither of those help me.
Well, you can do the 4 probably.
4 times?
6?
Help. 4 times 7 would be 28. Then we can take the square root of the 4 class,
2.
and we end up with a final answer of...
6.
Now, you may have done it and taken a slightly different approach. How many ended up with 6 times the square root of 7? Okay, Lexi did, but you didn't start with 9 and 28, did you? You started, I assume, with, did you do 4 times 63? Yeah, okay, and you also did 4 times 63? So if you start with those ones, take out the square root to get, class, 2 times the square root of 63, but hopefully you left it there, all right? Did you also leave it at 2? No, you took it all the way down. Anyone else leave it at 2 times the square root of 63? What square is still in the 63, though, Evie?
3.
Square.
9.
9 times
7.
7. There we go. And we'll take out the square root of the 9 to get
3.
Times the 2 does end up giving us the final answer, 6 squared of 7. So, again, I would try the shortcuts first. That's just me personally, because I love shortcuts. And if it's a big number, I'm like, there's got to be no, there's not a shortcut. So we have to do it one of the slow, painful ways. But we end up with 6 times the square root of 7. Questions on this one? Questions on that one? I hate it when there's not a shortcut. Yes, sir.
Which one could you do to get straight to that answer?
Well, if you somehow saw that this is 36 times 7, which we didn't memorize at high in our 7 times tables, and we never memorized 36 times tables, I mean, then you could get straight here, but it's unlikely you would see that. So it's probably going to be a slow, painful way. It's just unfortunate. All right, looking at the next one. Considerably easier because there were no numbers to factor. We're just dividing exponents and indexes to get Hayden.
AB times the square root of AB squared.
Cube root, right? So A, once, leave 1 left over. B, once, with 2 left over. There we go. AB times the cube root of AB squared. How many had that same answer on number 44? Question. All right, number 46, we have the cube root of 54. Now again, if this is a square root of 54, I like my 9. It's a cube root of 54, so I'm going to have to roll with what here, Aubrey? 27 is the key number. Now, there happens to also be a 2, but the 27 is the main number I'm focused on, because I can take the cube root of 27. But I'm going to have to leave as the cube root of 2. How many had 3 times the cube root of 2 for number 46? Questions on that? Did anyone say 3 times the cube root is 6 and you went 9 and 6 instead of 27 and 2? Okay, careful. Make sure we're looking at the right set of numbers, right? Square roots, these set, cube roots, this set. The last one there was the cube root of 32. And again, if it's a square root of 32, 4 and 8 would work, right? Or 16 and 2, because 4 and 16 would be squares. It's a cube root, so I'm not interested in a 4 or a 16, but I am interested in...
27. No.
27, a factor of 32?
No. 64.
64 goes into 32?
No, 8.
8! There we go. Let's not make it hard. There is an 8. It's just that 8's the main number here. 8 times...
4.
But again, it's not the 4 that I care about. Square roots, sure, I love the 4. Cube roots, I don't care about the 4. I care about the 8. What's our answer going to be?
2 times the cube root of 4.
2 times the cube root of 4. How many had that for the last one? Number 48, those who made it that far. Questions on these? Do we feel like, even if we didn't get them all, do we feel like we're starting to make some more headway here, starting to understand it a little bit better? Let's work a few more. Do 49 to 54. 49 to 54. Finishing out the page.
Have we done fourth root yet?
Fourth root.
50.
On number 50, let's see, fourth roots. Well, we got cube roots, right? We know we can take the cube root, look up here real quick. We know we can take the cube root of 8 because 2 cubed is 8. We know we can take the cube root of 27 because 3 cubed is 27. So really with fourth roots, if we want to make another little category here, we'd have to think through. Well, 1 to the 4th never does us good, right? But that's just 1. What about 2 to the 4th?
16.
So the fourth root of 16 would be something we could possibly use. What about 3 to the 4th?
81.
So the fourth root of 81 is something we could do. What's 4 to the 4th?
It's 16 squared, 256.
Yeah. I can't imagine you needing any more fourth roots than that. In that case, we've already kind of answered the question, haven't we? Number 50, class, it's actually rational. It's just going to be 3. The fourth root of 81 is 3. No, 4 to the 4th is 256. 3 to the 4th is 81.
If you want to go like the long, painful way for like the 4, because you know it's not going to be that high because it's like the 4 times 4 times 4 times 4.
Yeah.
You know it's probably not going to be like more than 5, so you could just...
Yeah. We won't see fourth roots that often.
Is it 25 squared? It's 25.
It's again, with the square root list, it's not to say you can't use 16 or 36 or 49, right? They're just not the main numbers I look for first, but they're there if you need them. Hayden finished? Thinking. Evie's finished. Aubrey, finished your thinking? Finish? Hayden's finished now? Just another minute or so to work on these. Bless you. Bless you again. You need tissue? I got the, I don't need no tissue.
Biology's correct. I took a bunch of graphs yesterday.
The last 2 times I mowed, I wore a mask. Forget coronavirus, I just don't want all the pollen in my nose. It's like I don't have masks laying around now anyway, might as well use them. All right, for sake of time, pencils down, look up this way, let's see how we did. Number 49, we had the cube root of 16. Evie, how did you factor it?
8 and 2.
8 and 2, right. If it's a square root of 16, class, that's rational. That's just 4. Cube root of 16, we're going to have to factor, she said 8 and 2, so our answer?
2 times the cube root of 2.
2 times the cube root of 2 is correct. How many had that answer on 49? All right, questions on that? Number 50, class, we already said is rational. It just comes out to 3. Okay, it happens to be a perfect fourth. Number 51, Glenn, this is a big number. And with big numbers, I like to try shortcuts. As we saw once before, they don't always work, but I like to try them. And so I could try splitting this into 2 times something, except that it's not even numbers. It ain't gonna work. So maybe I said, well, if you can't cut it in half, try cutting it into thirds. Try dividing by 3. And so if I split it up 3 times 121, does that help me? Yes, because the square root of 121 is 11, and I'm going to leave inside the radical the 3. Then I come to the letter. What's the exponent of the letter? And what's the index?
2.
And I've got to ask myself, how many times does 2 go into 1? But it doesn't, so leave the D right there with the 3. I guess I didn't need that gap after all. How many have 11 times the square root of 3? Do you figure that out? Okay, if you try to conventional means, you might drive yourself nuts. So that time the shortcut was really the only way to go. Number 52, we have the cube root of k to the 8th. Lexi, what did you do here?
You just say how many times does 3 go into 8, and it's 2 times, and you leave the k to the second and the cube
Root.
root.
So our answer is?
K squared times the cubed root of k squared.
Good. A little note I want to point out, by the way, make sure if you have an exponent, now this time we happen to have an index as well, make sure you maybe leave a little bit of a gap so that your exponent here doesn't look like your index. And if you do have an index, make sure you write it really tight in here to the radical so it doesn't look like the other. For instance, if this had been just a k and I had something like that, is that a k cubed or is that a cube root, right? So just a little note there, make sure you're very neat and careful as you write exponents and indexes. How many had the same answer Lexi had? K squared times the cube root of k squared. Questions? All right, looking at the next one, we have the cube root of 625. Well, cube root, so I'm not interested in these numbers. I'm interested in these numbers here. Danielle, which of those numbers do you think might go into 625?
125.
That's the first number I'm going to try. I might be sorely disappointed, but it's worth a try. 125 times?
5.
It does work out. 125 times 5, so our answer?
5 times the cube root of 5.
5 times the cube root of 5, because of course the cube root of 125 is 5. How many have 5 cube root of 5? For number 53. All right, then number 54, we have the square root of 500a to the 5th. And Hayden?
500.
Good, split this into 105, 100 times 5, I should say. So we end up initially getting
10 times the square root of 5.
Good, 10 times the square root of 5. So I'm going to leave a little bit of a gap. Then I'm going to come over here to the a to the 5th, Aubrey, and I'm going to ask myself, how many times does...
2 going to 5.
And the answer?
2
2 times, so
A squared.
a squared out here and a to the first inside. And how many had 10a squared times the square root of 5a for number 54, those who made it that far? Questions on the 4954? Questions at all on what we're doing right now? You're going to practice some of these in a short homework assignment tonight. Questions? All right, obviously, if you're watching on YouTube, Evan, Rocky, Jaden, Kyla, or Michael, let me know and I will get back with you. For homework this evening, I want you to do page 512. You're going to finish up that most of the homework section there. No, not really even that. You're just doing 34 to 44 the even, so it's really short. 34 to 44 the even. So page 512 in the homework section, just doing 34 to 44 the even numbered problems. Really short, quick assignment. We'll take a look at that in our next lesson. Have a wonderful rest of your day. When the bell rings, you'll be dismissed.